Now we're going to get into word problems. So sorry, I wasn't sure how to do it. I thought it'd be easiest if I did this in 2 videos, so that's what I decided at the last second. So word problems, 2 steps. Now we have to translate these word problems into an inequality, solve the inequality, graph the inequality, and then check our answer to see if we're right. So let's go through. We're going to do 2 examples together, and then we're going to have you try one on your own. Example 1 says Christian had $25 to spend at the fair. If the admission to the fair is $4 and the rides cost $1.50 each, what is the greatest number of rides Christian can go on? So they give us some steps up here that we're going to follow along here to again help us go through, have a strategy, have a process for this instead of just trying to go in blind. So these steps are a little bit different than the ones I had given for like figuring out the one-time number, the number with the variable, all those things. That strategy does still work here. If you're comfortable with that, you can keep doing that. It gets a little tricky because there's a bunch of different inequality signs though that you need to figure out because there's a few ways you could set this up. So we're going to go through with these steps. First, we're going to define the variable. And what that means is we're going to figure out which one of these numbers is the variable going to go with. Again, a variable means that we're going to have to multiply or divide a number with a number in the problem, and that's a number that's going to happen over and over and over and over again. So we have to think which one of these numbers is happening over and over and over again, because that's going to be my number with the variable. Is Christian going to keep getting $25 over and over and over again? No. Admission to the fair is $4. When you pay admission, you only pay one time. You only pay for your movie ticket one time. You only pay to get into an amusement park, a roller coaster place one time. You don't pay over and over and over again for admission. The rides cost $1.50 each. Each is a key word that it's going to be happening over and over and over and over again. So that tells me that my variable is going to go with this $1.50. So to define our variable, we're going to have $1.50 times n for the number of rides. So our second step, we want to write our inequality now. So we need to go through, figure out where the numbers go. So first off, we know we've got $25, we've got $4, and then we have our $1.50 with our variable. So out of those 3 numbers, what's kind of like our total, our one-time number, or our total? 25 is going to be our total, so that's going to be on one side of the inequality. If this was an equation, we'd have an equal sign there, but we don't. We have inequalities. So we'll come back and we'll figure out this inequality symbol here in a bit. Let's figure out what's going to be on the other side of our inequality. Let's figure out how much things are going to cost. We have the $4 plus the $1.50 and $1.50 for how much rides are going to cost. One side, that's how much money we have. And the other side is how much money we're going to spend. That's my 2 sides, what we have, what we want to spend. Now we need to figure out our inequality sign. Is it okay if we spend the exact amount of money that we have? Yeah, we can spend $25 exactly. That would mean we have a line underneath because it could equal 25 exactly. Now we need to figure out, are we going to go this way or this way with our inequality? Can I have more money than I spend? Can I have more money than I spend? Yeah. Can I spend more money than I have? We can't spend more money than we have. We're not going to have any more money to pay for any rides. So it's okay if we have more money than we spend. So we're going to have a greater than sign. So $25 is greater than or equal to $4 plus $1.50 n. There was us solving or writing our inequality. Now we need to go through and solve it. It's been since before break since we've solved inequalities. If you need a refresher, you might want to go back and check out that two-step equation video. But we want to draw our train tracks. Then what do we want to do? Put the box around our coefficient and our variable. Who are we trying to get rid of? That third wheel on the date. How am I going to get rid of that third wheel? How am I going to get rid of that 4? It's a positive 4, so I need to subtract 4 on both sides. 25 minus 4 is 21. My 4s are opposite, so they eliminate each other. They cancel each other out. I bring down my $1.50 n and my inequality sign. Now that we're here, again, we're trying to isolate our variable. We're trying to get our variable all on its own. What do I need to do to isolate that variable to get it on its own? What operation is that when they're side by side? That's multiplication. So the opposite is divide both sides by $1.50. Again, we're dividing by $1.50. A lot of us might want to subtract because the $1.50 is positive. We have to do the opposite operation, not just the opposite if it's positive or negative. No shame in the calculator game. So we're going to do 21 divided by $1.50. And we get 14. My $1.50s cancel. I bring down my n. We got to think for a second. Is this inequality sign going to flip direction? It will not. Remember, we only flip if we multiply and divide both sides by a negative number. So our inequality sign here does not flip. It's going to stay the same. So we get 14 is greater than or equal to n. So now we need to go through and graph it. We need to go through and graph our answer. So we had an open circle sometimes when we graph and a closed circle sometimes when we graph. When do I have an open circle? Less than and greater than. The regular sign's just an open plain circle. But if I have the line underneath, if I'm extra with my sign, I got to be extra with my circle. I would have to color it in. So here we know our answer's got to be 14. Open or closed circle? Closed. Why is it closed? We've got our line underneath. Our line underneath makes it a closed circle. Now I got to think. Am I going to shade to the right or am I going to shade to the left? 14 is greater than or equal to n. Let's choose a number to check and see. So on this side, it's easy to check the number 0. Let's plug in 0 to check to see if 0 works. Is 14 greater than or equal to 0? Yes, it is. Let's try 20. Is 14 greater than or equal to 20? No, 20 is too big. So that means we need to shade what direction? That means we need to shade to the left. That means we need to shade to the left. We should have a closed circle, shading to the left, and we already checked with 0 and 20 to see if our answer makes sense. If I don't write any rights, that's okay. I still have plenty of money. If I ride 20 rides, I'm not going to have enough money there. I'm not going to have enough money. Okay. Whew. A lot of work, but it's worth it. This is very real life stuff. I know I like to go to those carnivals, and when I take my money, can't spend more than I have. I need to make sure that I take the time to do some math to make sure I don't run out of money. I've got to get my corn dog, and I've got to play some games. All right, so example 2. We're going to kind of do this one together. I did that last one. We're going to do this one together. Example 2. The 7th grade class is putting on a talent show to raise money. It costs $700 to rent the banquet hall that they are going to use. If they charge $15 for each ticket, how many tickets do they need to sell in order to raise at least $1,000? So go ahead, try figuring out the variable and the inequality. I'm not sure why that's an E. Not sure why that's an E. It should be an I. Might have not copied it right from equations. That should be an inequality. So go ahead, pause the video, write the variable and the inequality for me. Just those first 2 steps. All right. So hopefully in reading the problem again, you recognize that keyword each means that number is happening over and over and over again. So $15 times the number of tickets is going to be our variable defined. Setting up this inequality is a little bit tricky. We have their goal of $1,000, and then we have to calculate how much money they've raised. Their goal $1,000 and the money raised. So the money raised is $15 times every ticket that they sell, but it cost them $700 to rent the room first. So they have to subtract that amount of money to figure out how much money they've made. They have to make up that $700 because they need more than just $300 to meet their goal. If they only made $300, they would still be in the negatives. They'd be negative $400. They wouldn't be toward their goal. So they have to pay for the tent plus some extra money to meet their goal. That's why that subtraction sign is in there. That word cost means it's a negative $700. So then for the inequality, is it okay if they raise the exact amount, exactly $1,000? Yeah, that's okay. Is it okay if $1,000 is greater than how much money they raise? If $1,000 is greater than, bigger than how much money they raise? We don't want that. We want the money they raise to be equal to or bigger than $1,000. If you need to go through and fix that inequality, please do. If you have questions about yours specifically, about why it is or isn't correct, please come find us. Otherwise, go ahead and just solve it. Just go through and solve those 2 steps for us. Hopefully you get that 113.3 repeating is less than or equal to n. Less than or equal to n. But can I sell part of a ticket? I can't sell part of a ticket. I cannot sell part of a ticket. So they need to sell 114 plus tickets to meet their goal. Because again, I can't sell part of a ticket. So when we're going to go through and graph this, because this answer doesn't make sense, I can't sell part of a ticket, I have to sell a whole ticket. We're going to make our answer on our line for our inequality be at 114. Go ahead, pause the video, and I want you to graph and check. Like how we did up here, check, graph it, and check your answer for me, please. Hopefully you shaded to the right. Hopefully you shaded to the right. because it's okay if they sell more than that. If they sell more than 114 tickets, they're going to be having so much money they don't even know what they're going to do with it all. But we can't sell less than 114 or we're not going to reach that goal. Go ahead, try example 3 on your own. We get some ugly kind of decimals in there. Do not turn that into a dollar. Leave it at 99 cents. Do not round it. Leave it at 99 cents. Use your calculator to help you out. Try example 3 all on your own, and then come check in with us teachers so we can let you know how you did on that example and the examples from this page. Good luck.